Hello, ladies and gentlemen. This is Mr. Bryce from Susquehanna Valley High School here in Conklin, New York. There's my email address. Today's special guest is Carl Gauss. You'll find out a little bit later. We're doing Unit 5, Lesson 3, pages 9 through 12 in the packet. If you don't understand what I'm saying, the genius that made these worksheets, you can scan that QR code right there and learn from him. Okay, we are doing the non-regents Common Core Algebra 2, and we're going to talk about arithmetic series today. A series, by definition, is simply the sum of the terms of a sequence. The fundamental definition of a series is below. Okay, now that's kind of difficult to read because it's math speak, but we have a set of numbers, and we're going to call it S sub n. So the sum of those numbers from the first number, if we want to start the first, to the last number, and you just plug in each number. Seems very straightforward. We're just adding up all the numbers. In truth, you've already worked extensively with series in previous lessons. Almost any time you've evaluated a summation problem. In other words, you have to add up all these numbers. So exercise number 1, given the arithmetic sequence defined by the first number is -2, and every number after that is the previous number plus 5. So that's previous number. This is the current number. A lot of times I also talk about it as my number, and then we just add 5. Then which of the following is the value of the sum from the first number to the fifth number? So the first number is -2, and then the rule is add 5. Then the rule is take that number and add 5. Then take that number and add 5. 1, 2, 3, 4, and then the last one, add 5. Now add them together, and we get 40. So simple, you just have to do a long process of finding each of the numbers. The sums associated with an arithmetic sequence, known as an arithmetic series, have interesting properties. Many applications and values can be predicted with what is commonly known as the rainbow addition. Really? That's the first time I heard about that, so I wonder how common it is. Consider the arithmetic sequence defined by the first number's 3, and then every number after that is the previous number plus 2. The series is based on the first 8 terms of this sequence shown below. The terms have been paired off as shown. Okay, so they wrote down the terms, and what is the sum of each pair? So what is 3 plus 17? 20. What is 5 plus 15? 20. What is 7 plus 13? 20. What is 9 plus 11? 20. We have an even number of numbers, and each pair adds up to 20. We have an even number of numbers, and each pair sums to 20. Okay. Why does this make sense that the sum is constant? Okay. Well, just the obvious answer. It is linear, so there's a constant rate of change. Instead of saying there's a constant rate of change, I'm going to use the mathematical abbreviation for rate of change, delta y over delta x. How many of these pairs are there? 1, 2, 3, 4. How many numbers were there? 8. Okay. Using answers to A and C, find the value of the sum using a multiplicative process. So this is very simple. but I'm not going to get ahead and answer E yet. Let me see. There are four pairs, and they all add up to 20. So the sum is 80. Generalize this. Now create a formula for an arithmetic series sum based only on its first term and its last term and the number of terms that we have. Well, ladies and gentlemen, this is where Carl Gauss comes into play. Let me see. We have a pair, so if the number of terms, and we're going to pair them, so how many pairs do we have? Pair up, pair up, pair up. Yeah, that's right. The number of numbers divided by 2, so that will be the number of pairs. And what did we do with it? We added the first one, and we added the last one, and it's going to be the same sum for all of them. So here, there's the number of pairs, and that's the sum of a sub 1 plus a sub n, the first one and the last one. Now, what are we going to call this? Well, that's what we call it, S of n. That's very important. Let's take a look at the next page. There it is. Which of the following is the sum of the first 100 natural numbers? Show the process that leads to your choice. Okay, natural numbers. They start at 1 and go up to 100, since it's the first 100 natural numbers. Now, it doesn't mean that, since the first 100 natural numbers, it ends at 100. If we would have said the first 100 whole numbers, it would have been from 0 to 99. Okay, so now we have to, let me see, they add up to 101. So first of all, there are 100 numbers. We're dividing it by 2 because that's the number of pairs. And then we have 1 plus 100. That's 50 times 101. The answer is choice 4. Remember, if you have any questions during this time, just ask me in class, rewind the video, listen to it again, ask me during a study hall or after school. Find the sum of each arithmetic series described or shown below. The sum of the 16 terms given by. I'm glad that it said 16. That means that I don't have to figure out how many terms there are. So it's going to be 16 over 2, and then negative 10 plus 50 is 8 times 40, 320. The first term is negative 8. The common difference is 6. There are 20 terms. Wow. Okay, so now remember, for this problem, we need to know how many terms there are. We got it. There are 20 of them. We need to know the first term and the last term so we can add them up together. Well, the first term is negative 8, and now we have to, and there are 20 terms, and we have to figure out what the last term is. Do you want to figure out what all 20 terms are? Of course not. Then we just might as well add them all up together. We can use this formula that we did a couple days ago. So that is my number, the number that I'm looking for, the nth number. So a sub 20, the common difference is 6, and then 20 minus 1 plus the very first number. Crunch that, and we get the 20th number in this is 106. So now we still have to find the fact that there are 20 numbers divided by 2, so this is S of n. The sum of them is number of numbers divided by 2 plus the first number and the last number, and that equals 10 times 98, which is 980. The last term is the 12th term, and it's negative 29. The common difference is negative 3. So we still have to use what formula? Let me see a formula. What formula are we going to use? Question. Oh, yeah. We're going to use this one that we just had up here. A sub 12 equals, or, we can use A sub n equals the difference. The difference is negative 3. The number of terms is 12. And we don't know what the first term is, but we do know that the last term is negative 29. Negative 3 times 11 plus the first term. And then when we add 33 to both sides, we get the first term is 4. Now we actually have to do the work. I hate it when you have to work from right to left. But we're going to do the number of terms divided by 2, and then the first number plus the last number, and that's going to be the sum. So the number of terms is 12 divided by 2 times the first number is 4, the last number is negative 29, and that's going to equal the sum. Let's type this into our calculator, and we get negative 150. Find the sum of these. Well, I'm still going to grab that same formula because I want to know what n is, how many numbers there are. So a sub n, that's the last number, 77, equals the difference. The difference between them is 3. And then plus the first number. Subtract 5 from both sides. Divide by 3. And then add 1. So there are 25 numbers in the series. Now, what we have to do is in the sequence. Now what we have to do is we have to add up the series, n divided by 2, the first number plus the last number. The number was 25, n was 25, so I'm just going to erase that because I'm running out of room. I'm going to put 25 over 2. Now notice I'm going to get an odd number here. 25 divided by 2, not an odd number, but an odd number divided by 2. So 25 divided by 2 is 12.5. And let's see if we're actually going to get a decimal here. And we're adding up integers, and so I better not get a decimal. I better get a positive or negative whole number. So what is 12.5 times 82? 1,025. Beautiful. In exercise 5, Kirk has set up a college savings account for his son, Max. If Kirk deposits $100 per month in an account, increasing the amount he deposits by $10 per month, then how much will be in the account after 10 years? Well, 10 years is 120 months. So let's see if I can use the n divided by 2, and then the starting amount plus the last amount. That's going to equal the sum. So if we go down this road, we see that it's 120 divided by 2, and then the first amount is $100, and we don't know what the last amount is. So we have two unknowns, so we've got to grab another formula. And you guessed it, these are used hand in hand all the time. So the last term, A sub 120, is the difference. He's depositing $10 per month times 120 minus 1 plus the first deposit, $100. And when we crunch that into our calculator, we get $1,290. Now that is the last deposit. That's not the total amount that he has in the account. That's the last deposit amount. So now we go back here and we take a look at the equation. What do we have to fill in? 120 divided by 2 is 60. 100 plus 1,290. Crunch that on our calculator. And we get $83,400. A nice tidy sum. You think increasing a deposit amount by $10 a month, that's not very much. That's only increasing it by $120 a year. And so, yeah, that is very doable. In 10 years, having $83,400. That doesn't include any interest that you'd be receiving on that. That's just putting it in the mattress. Okay, ladies and gentlemen, that concludes lesson 4. If you have any questions, make sure you ask me in class. You know what your homework is, the next 2 pages. Have a great night.